Welcome to our MIU today. My name is Maximilian Reimann and I will guide you through our event today. Before we begin, just a few quick reminders. Please make sure the mute function remains enabled and do not unmute yourself during the presentation. Kindly turn off your cameras as we will starting a video recording shortly. If you have any questions, feel free to raise the hand feature or wait until the end of the presentation to talk to our speaker directly. Thank you. And that brings us already to today's presentation. I'm pleased to welcome my valued colleague, Ms. Shanduzi Bhattacharya. Shanduzi has a master's degree in data engineering and several years of experience as a systems engineer and data scientist. She has been researching at the Fraunhofer CML in the field of maritime operations management for almost 4 years now. We're looking forward to the presentation with the topic Geared Rope Integrity Prediction, aka GRIP. Shanduzi, the stage is yours.
Thank you, Max, for the introduction. Good afternoon, everyone. And today I would present the topic of GRIP. And the topic is about automated and digitalized inspections of steel hoist ropes that are used in harbor cranes using modern sensors and AI-driven technologies. Before diving into the motivation and objectives of the project, I would like to share this picture. So this is taken from the top of an STS crane, and you can see multiple steel ropes here. And these ropes are responsible for hoisting the load. It is very important that these ropes are kept in good working condition because they are very important for safe and efficient working of these cranes. That is why these ropes are inspected from time to time to ensure that they are in good condition. So currently, the inspection process is completely manual. So the inspector climbs up on the top of the crane and then looks at the ropes visually. And by seeing this picture, you can already imagine that it would be quite time consuming and exhausting to inspect such lengthy ropes and so many of them. This is an cutout section of the hoist rope at the end of its service life, and it is damaged severely. And you can see already many wire breaks here. Some of them are highlighted, and wire breaks are one of the most commonly occurring damages in these ropes. Yeah, so after our contact with some of our industry partners, we came to know about the challenges that they are currently facing with the manual inspection. One of the most important challenge is the cost of these inspections. So it costs around 4,000 euros to inspect just one rope during its lifetime. So for one crane, it's around 16 to 32,000 because each crane has around 4 to 8 such ropes. Then it takes around 16 plus hours to inspect them because they are around 150 to 200 meters in length. And these also leads to some equipment downtime related costs. Moreover, such manual inspections are always prone to human errors. Some damages might go unnoticed. It is the entire section of the rope is not always visible due to its structure. And another major concern is the cost of these ropes. They are quite costly. It costs around 10,000 euros for each of them, and they are currently replaced after every 2 years, even if they are not damaged at the end of their guarantee period. And that's a wastage of perfectly good material. So keeping these problems in mind, the idea of GRIP was developed to have an automated and digitalized system which would be capable of taking the observation of the ropes and assessing it with the help of intelligent algorithms and decide on the condition of the rope. And with this idea, we see certain cost benefits because such a digitalized idea solution can be developed in quite low costs, and a couple of such systems would be sufficient for the entire port, and they would have a more lifetime than 2 years. So if we look at the total inspection costs of the entire port, it would be reduced significantly. Then the system would definitely be in total compliance with the standard norms that exist for inspection of these kind of ropes. And moreover, there is also a possibility to extend service life of these ropes, as the sensors would have in-depth information about the current situation, and they can have a very close-up look, which is not possible right now. And along with the assessment of the AI algorithms, yeah, that seems to be possible. So the idea of the solution is of the current project is to use optical sensors to take images of sections of rope, and these images would then be transferred to a computer vision algorithm. This algorithm would detect what type of damages are present in the section, in the particular section of the rope, and mark the area of damages. And then these outputs would be used by another evaluation algorithm, which evaluates the current condition of the rope and makes a decision that what should be done with it. Yeah, should the rope be discarded or monitored frequently, or is it operational? So yeah, it makes it first localizes the damage, that where on the rope, which section of the rope is currently being inspected, and then assesses the severity of each kind of damage using the outputs from the damage detection algorithm, and then gives out a final assessment about what to do with the rope. Then all these assessments would be used to formulate a inspection report, and all of them would be visible via an interactive dashboard where the inspector would be able to see the raw data that is captured by the optical sensors, and also the assessment that is provided by these algorithms. Yeah. So the goal of the project is to develop a working demonstrator which shows the capabilities of optical sensors and AI algorithms to carry out such automated and digitalized inspections, and this would develop a proof of concept of our idea of digitalized rope inspections. And this project is funded by Leistungszentrum EML, and for a period of 6 months. Our team consists of 3 members, and I and Joshua Weitzmeier are working on the technical aspects of the project, and Maximilian Reimann is involved in the business development and collaborating with potential clients and market readiness of the idea. So in a duration of 6 months, we already had our first kickoff in early April, and we planned how to proceed with the project and did some data collection from actual hoist ropes and some sailboat ropes, and we are currently working on developing the software module of the project. And yeah, we have 2 more months to go. With this, I come to the end of the topic. And thank you very much for your attention.
Yeah, thank you very much, Shandazi, for the interesting presentation and the shared insights into the topic. So currently we don't have any questions from the audience, but I do have 2 questions. The first one is how the grip system can be safely used in real life, since AI models are not always 100% accurate, and safety is quite crucial in crane operations.
Yeah, you are totally right. Safety is one of the major concerns, and that's why we plan on using a hybrid approach. So in the beginning, yeah, like we want to deploy this automated system, and there would be an inspector, maybe from the terminal or an external inspector who would just look at the dashboard. Then he would have the raw images and also the assessment of the models. Then if there are any misinterpretations by the models that can be detected, also our interpretations would be validated, and there would be still some time savings in the initial stages because the inspector doesn't have to climb up on the crane and look through 200 meters of rope. And in the long run, when our system gains enough trust, then the involvement of the human involvement or the frequency of manual inspections can be reduced, and that would lead to significant cost savings over time.
Okay. And as we still don't have any question from the audience, my second question is basically if there are already other automated inspection solutions for steel wire ropes, and to what extent grip is comparable, or like how does it offer added value in comparison?
Yeah, there's one company that has developed a system, a camera system to inspect such ropes, and a few other companies are also using it. So in this case, there is a camera system which takes pictures and continuously transfers it to a data station where an experienced personnel is sitting and just looks at the picture and makes a decision based on it. So it does not involve any automated analysis or an involvement of an AI to interpret, already detect what damages are there, or assess the severity of each of those damages and make an informed decision. So this is where GRIP adds value and makes the system completely, digitalized.
Yeah, perfect. Thank you very much also for answering the questions regarding this quite interesting topic. And yeah, that brings us already to the end of today's event. Please feel free to get in contact with Sanusi if you have any questions that may arise after today. You can find her contact details on the slide. And we will continue with our MIU series on the 25th of July, 2025, so next week, Friday. And the presentation will be Keylog, developing LLM agents for maritime logistics tasks by our colleague Emin Nagic. Have a great weekend, and thank you again for your interest in today's presentation.